2 seconds. Here we go. So welcome to the University of Glasgow's first study jam. Today we'll be covering all things Kotlin, and there will be some activities for you to do once I'm done with a quick live coding session with you guys. But before we do that, I have to quickly mention about the Google Solution Challenge, which is now live. So what exactly is this Google Solution Challenge? Well, the Solution Challenge is a software development competition for students all over the world. This year's challenge is being delivered in conjunction with the United Nations, and the goal is to develop a solution which addresses one of the United Nations 12 Sustainable Development Goals. So teams up to 4 students can submit demos of their solutions by the end of March, and the top 50 will progress to the next stage. All you need to do is register with our charter and our group, form a team, and start building. So we will run several workshops like this Android study jam between now and March 31st, as that will be the deadline to help you leverage the Google technologies and refine your solution demo. Teams who progress beyond this round will work with Google experts to flesh out your solution and a chance to win top prizes. So how do I join? This sounds amazing. Well, all you need to do is, I think the rest of my team will post these links into the chat. You just need to register for the Solution Challenge by becoming a member of our charter, registering with Google on this URL here, joining our Discord server, and writing a message in the Find a Team channel. Now, all you need to do is write a quick message saying, look, I'm looking for a team, I've got this idea, whatever, and then tell us that you've created a team afterwards. And this is our charter here, isn't it beautiful? Look at that. So, some prerequisites for this study jam, basically. Assuming that you're in the right place, you're new to programming, here are the prerequisites that might be helpful for this track. So having a basic computer literacy skills and basic math skills is recommended. Obviously, you'll be needing a computer and some headphones to listen to the tracks and an internet connection. And it's absolutely optional to have an Android device. You can run an Android emulator on your computer. So if you don't have Android, don't sweat about it. Don't worry. You can just do everything that we're going to do in this without an Android device. So Kotlin. So we need to talk about why we're using Kotlin and not Java. Well, the main reason is basically that Google is allocating most of its resources now into the development for Kotlin for native Android development. And this shows in the industry. Over 60% of the professional Android developers now use Kotlin, and it was first started in 2010, but was first published in 2016. So it's kind of a baby programming language, to be fair. And there's a lot of aspects about Kotlin, such as code safety, which we'll get into later when we're doing the live interview, or code review, I mean. So some basic advantages of Kotlin. So it's an easy language, it's concise, better performance, small runtime, sometimes in comparison to Java, and it's interoperable with Java as well. So you can use Java libraries in Kotlin and vice versa. It's actually really dynamic in terms of when you're developing your Android application. We also have something called type inference, which we'll get onto when we're doing the live coding session. For you guys, what I want you to do is, if you could Google Kotlin Playground, this is where you'll be coding and doing all these exercises and working with me while I'm doing this live coding session. The site looks something like this, and you can write your code in the window and hit the green arrow to run it. The results of your code, well, known as the output or the console output, will show at the bottom window where it says "Hello World." So without further ado, let's get started. So just give me a second to get everything set up. While you guys will be using Kotlin, I'll be using an IDE from JetBrains, just because it makes the syntax makes it look a little bit easier for you guys to understand. So presentation mode, and there we go, c'est la vie. So, right, okay, so in your Kotlin Playground, you will be presented with this function called main. Now, what exactly is this? Why is it important? Well, basically, this is the program counter, the start of where your program will get executed. Will be right within this main function. So what we're going to do right now is we're going to say hello world for everyone that's in our study jam right now. Hello world. If you've been programming before, you know this is the classic hello world program that everyone, when they're first programming, doing anything, will write. And it just basically sends your output to the console here, and it says hello world. In Kotlin, one thing important to mention is that these semicolons, if you've worked with Java or C++ or C, these are completely optional. You don't need to include these or not. It's just for style and preference. So you can compile your code with a semicolon at the end of each of the statements or without. It's entirely up to you. It's free choice. So before we get into anything serious, we'll go and talk about variables. Now, in Kotlin, there's two main I say types of variables, but it's more like you can define a variable to be immutable, which is technically not a variable, it's more like a constant, or mutable. Now, and you're probably wondering, if you've never programmed before, what does this mean? Just basically means, I'll type something in here right now. Say, for example, I'm going to say value name, and I'm going to say John, right? All this means is that when we define this variable, so we're going to give this variable a name, and we're going to assign it to John. Val just means it's a constant, you can't change it after the fact. So if I do something like this, and say Smith, this IDE here gives us a warning. It's like yelling at us, basically saying, actually 1 second. It's basically saying to us right now, look, the value cannot be reassigned because it's not a variable, it's just a constant. So we could change it to a variable right now, and that allows us to change it to whatever we want after the fact. And there's some reasons why you want to do this and why you wouldn't want to do this. For example, if you don't want your data to change, you would just keep it as a value. If you want to change it, keep it as a var. Cool. Right, so the next thing I want to cover is top-level variables. So top-level variables are basically within this file and this line of code here, any code can access these variables. So it's almost like if you've worked with other programming languages before, it's almost like a global, but only to this file. So we can do something like var age integer. Oh, a little bit of lag there. And we say it's 21. Now, within our main function, we can actually call this and, well, I say call, reference this, and print out to our console. And look, we've got 21. That's pretty cool. Right. Let's clean things up a bit. So we've already talked about variables changing, variables not changing. But one thing we haven't talked about is code safety, which is in Kotlin, variables can't be null. So what do I mean by that? So say that you didn't want to give this age any sort of data. You just wanted it to be null, like nothing. In Kotlin, as you can see, my IDE is being angry here, and it's like null cannot be a value of null type int. This is because Kotlin by default says we can't use null values for variables. And the reason for this is very simple. If you've ever programmed before, you've came across a null pointer exception. And a null pointer exception just basically means that this variable does not reference anything. Sometimes, though, you want to be able to nullify a variable. So all you need to do is add a question mark to it, and there you go. You fix the problem, and Kotlin's now happy. So if you want to define null variables, we just put a question mark after your type. Something that I've probably not skipped over really quickly for you guys is types. So in Kotlin, you don't need to define a type with your variables. It's implied from the data, but you can if you really want to. So for example, in this variable here, this is my name here, Fabrizio. You can, in Kotlin, it will automatically detect that that's a string. So instead of writing this, I can completely eliminate that, and now the variable is now, instead of age, let's call it name. That makes a little bit more sense, doesn't it? And now that's also a string. Okay, so that's the basics of variables within Kotlin. And there's many different types of variable types. We could have integers. So we'll go back with the age example, just because it's easier to understand. We could have doubles. So like, for example, height. We could have a double, which is anything with like a very precise floating point value. Again, strings, we can have characters, and this just defines different types of data. Again, if you've programmed before, this is probably annoying you because you've probably heard this in like 1,000 programming tutorials, but we're just doing this for the time being. So next, I want to move on to control flow. So like if statements, switches, while loops, for loops, that sort of thing. So we'll start off with an if statement. So for example, let's say we've got a student, right? He's in his first year, and we want to check if he's 18 or not for going into like the union or not or whatnot. So, for example, we can do an if statement here and check for his age. If his age is over the age of 18, for example, we want to do println and we're going to allow him in, right? It's allowed. Cool. And we're going to run this code here. Allow, and this is because he's not over 18. That's why that's not printed out in the console. Here we go. So now he's allowed, and we can see that out in the output in the console. But what if we want to check if he is the age of 18? We want to do something else. We actually want to check his ID, for example. And we'll do that quickly here by saying check ID. And we'll change him back to 18 years old. Now, as you can see, it's check this first if statement, checked if he's over 18, he's not over 18, so if he is 18, let's check his ID. And let's do a default statement. Now, the else is basically a follow through. If nothing else works out, we're just going to print this, and we're going to say he is not allowed. Right? And we will change him to under 18 and run the code. And as you can see, he's not allowed. So this is pretty much the same across most programming languages like C and Java. You know what an if statement looks like if you've seen it before. But for those who've never seen it before, that's what it is. We can also do while loops within our program as well. So I'm going to define a variable called reps. If anyone's been to the gym before, a rep is just a repetition in the gym. Let's just do a loop for this guy. Is doing his reps and he's not finished his 10 reps. So we're going to do a while loop and we're going to print line and we're going to tell him one more rep. There we go. So he's going to do one more rep, and then after he does his rep, we're going to decrement reps by 1. Okay. So what is going on here with this minus and equal sign? Don't worry, it's really simple. It's just a shorthand for doing this sort of assignment here, where you've got the 10, you're doing 10 minus 1, and now it's going to be 9. So that's just it's just a shorthand way of doing it. So let's see what the output of this is like. And as we can see, it's repeated this 10 times, or 9 times it should be, yeah. And there we go. And that's how you do a while loop. It's like many other languages if you've seen it before. Quickly, let's go into for loops. So for loops are really useful. The reason being for them being so useful is that you can define how many times you want the code to run. So we're going to just define a random variable in Kotlin, and we're going to say it's counts. And this is going to be our index as we go through each loop. So the first loop count's going to be 0, second loop count's going to be 1, etc., up to some point. And Kotlin's got a really cool syntax. So you can say count in 0.10, right? And this is going to run 11 times. It's going to start from 0 and go count all the way up to 10 inclusively. So we're going to do println, and we're actually going to print out the count, so just so you guys can see what's actually happening here. So as you can see from the output, we've got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and it's done this loop 11 times because this is inclusive. We're going to include the 0, include the 10. It's really nice, easy syntax to use. It's actually really reminiscent of Python. We can also do a countdown as well. So we can do count in 10 down to 1, for example. And now we're going to do this 10 times and count down to 1. And as you can see, it just does the opposite in our terminal output here. 10, 9, 8, 7, 8, 6, 5, 4, 3, 2, 1. And like Python, we can also do steps as well. So we can do a quick step, 2 steps, and we're going to count down all the even numbers as well. Down from 10. So 10, 8, 6, 4, and 2. Cool. So that's basic for loops within Kotlin. It's really nice, it's really clear, it's really concise. Next, we're going to cover switch statements. So switch statements in Kotlin are called when statements, I guess. So say, for example, we have a password here, and we're going to store it in a type string. And we're going to say our password's 1, 2, 3, 4, 5, 6. Okay? So we're going to say when our password is equal to some value. Okay, so 1, 2, 3, 4, 5, 6. We're going to do something. We're going to print the output, and we're going to print user logged in, just as a silly wee example, right? So we're also going to have another statement saying if the password or when the password is equal to admin, we're going to say admin logged in, right? And then you can do a default statement here. If none of these match, we are just going to say not allowed in. There we go, or access denied. Access denied. There we go. So let's give this a rerun and see what happens. So as we can see in our output, user is logged in, and that's because our password matches. So let's see what happens when we change this admin real quick. Just run that code. Admin logged in. See, the if statements went down here, it's passed in the password, and then just went to admin and said admin logged in. Let's put some bogus string in, some random brute force password, and we're just going to log it in, and we can say that's access denied. So that's a switch statement, and it's really nice and handy for doing a lot of if statements grouped together under one variable. So we're going to talk about collections now. So what exactly are collections? Collections are like your normal data types. So for example, arrays, lists, and maps. And if you've never seen this before, don't worry, I'm just going to quickly cover these over. So for example, let's say I wanted a list of some Fibonacci numbers, right? So Fib numbers. We can create a list of them by using this helper function here, list of. And then we can just put in the variables or the values that we want inside here. So say we've got 1, 0, 3, 3, 2, 5, and 8, right? So we've got some Fibonacci numbers in a list, okay? But there's a problem here. Say, for example, you're pulling this data from a database or something like that. You're doing a GET request from an API, or you're just grabbing it from the internet somewhere. More times than not, this data is going to be completely unsorted. So there's actually quite a nice wee function here just to quickly sort this data. And it's called sorted. And what we're going to do is we're going to assign our Fib numbers to this sorted variable. And this is going to sort all our values for us within our list. We can also print out the size of our list by doing Fib numbers dot size, and that will just print out the size if I can spell it properly. There we go. And as we can see, 6 appears because there's 6 numbers in here. Cool. So that's how we print out our size of our list. If we want to do indexing, so for example, what is indexing? Indexing is basically if we've got a list of numbers for here, our Fibonacci numbers, and we want to get the first element in our list. We can do Fib numbers brackets 0 bracket. And as you can see in our output, we get 1. Actually, you know what? I'm going to cancel out the sorted just so it's easier for you guys to see. So 1. Index 0 is 1, because in our list, the position 0 is at 1. So if we move the index to 2 and we count up, so we go 0, 1, 2, we'll get 3. And this is not the only way to index in a list. We can also use this helper function, this getter function, and call our getter there. And as you can see, we can also index from a get function as well. So that's how we index with our function. How about something more interesting? So how about iteration? So say we want to do something over every element in our list. So what we're going to do is we're going to do for number in our Fibonacci numbers. And that's the really handy syntax. All we need to say is for our number in our Fibonacci numbers, and then we can reference that number. So for example, in the first iteration of the loop, we're going to get 1, second, we're going to get 0, so on and so forth, up until 8. And all we're going to do is we're going to print line, and we're going to print this number out. So have a look here. So as you can see, we've got 0, 1, 2, 3, 5, and 8. And the reason it's in order is because we've called sorted here before. Now, this is all fine and well. This is the de facto standard for writing a for loop. In most languages, you write a for, then you do some curly braces. But also there's a functional way to do this as well. So we can write Fib numbers and do for each, enclosed in some curly braces, and we can say our number here, and then do print line. And we can say print line number here and run our code. And we get the same output. So we've done the exact same thing with only using one line of code, and that's quite powerful. Because we are using a lambda expression here as well, and a lambda is just basically, we'll get into that later, but it's basically a function that you define within parameters. We can take out these parentheses right here and make it look even cleaner. So we only have these brackets, and we can do the for each like that. For example, what if you wanted the index as well as the number as well? So we're going to do for each index, and that will give us our index as well. So we can say here index number, and we're going to print our number and our index. And now I'm going to do something really cool. So I'm going to call our index here, and we're also going to show our number. So what this is actually doing is iterating through our loop, but also telling us what position each number is. So we're going to call this right now. And as you can see down here, we've got position 0 is 0, position 1 is 1. And remember, this is because it's sorted. If we take out the sorted and we run this code again, we get it in the order that we defined it in. Okay, cool. Now that's all fine and well. What if you wanted to add things to the Fibonacci numbers, for example? What if we wanted to add another 8? Well, unfortunately, you can't really do that without copying the whole variable. But there is a type in Kotlin that will let you add things. So it's called mutable list. And we're just going to call it here, and we're going to say it's here, mutable list of numbers. And in this case, it's going to be integers. So we can do here fib numbers, and we can add an additional number if we want to, right? So for example, if we want to add 3, we can add 3 onto our list, and now we've got an extra number in our list. Cool, right? So that's mutable, and for actually, you know what? I might as well, yeah, I might as well show you the output for each. For fib number and fib numbers, print line fib number. And there we go. Assuming that I didn't delete the last line of code to add the 3. Okay, I promise we'll get it right this time. Okay, so we've added our extra 3 to our list now. Cool. So that's all it is. List is just a collection of numbers, strings, or any type of data that you want to store. We're going to talk about maps. We're going to leave out arrays for the simple reason that in this context, the array of function is so similar to the list of that you might as well we're just going to cover lists for the time being. But if you want to cover arrays, it's the exact same way. But we're going to move on to maps. Now, the reason to use a map is if you want to quickly index within your list of things. For example, if we had a map, okay, we're going to, you know what, we'll create one. Name to age, and we'll do a map of, and we're going to say people's names. So we're going to say Dave, and we're going to map Dave to his age, and we're going to say Dave's age is 23. And also we've got Jane as well. We're going to map Jane to 19, so on and so forth. And we've got Axel over here as well, and we're going to see he is 20. Right. So we've got this map. So what's so important about this map? Well, what we can do with this is, instead of indexing by a number, we can actually index by the string or the name of the person in this case. So we can do name to age, and then we can index here, and we're going to say we're going to look for Dave. Okay. And here in our console output, we can actually see that we've got the age 23. So we know that Dave is now 23 years old. There's another way to do this, and it's the exact same as the list. We can do it this way as well, and we can get Dave's age that way. But it's a little bit cleaner to do it by the brackets. So So that's indexing. How about iterating over a map? So iteration over a map, if you've worked in any other programming language before, you know it comes in a pair. So usually it's like an index and a value, or the key and the value in this case. In this case, our keys are the names and our values are the ages. So we're going to say pair in name to age right here. And then we are going to do something slightly different to get the data that we're looking for. So we're going to say here pair dot key, and we're going to do a wee semicolon, and we're going to do pair dot value. Now all this is just saying is if we get Dave to 23, we're wanting to print out Dave here, and we're going to print out 23 here. And 23 is our value, and the key is our Dave. So, but we're going to do this for every element in our map. So let's do that here. Dave's 23, Jane's 19, and Axel's 20. Cool, right? Exact same thing with the lists. We can also do our for each iteration here, and then we can quickly do this because I don't want to bore you guys. We've got pair dot key here. So we've got a pair key, and then we're going to do the exact same function as before, but we're going to do it in a functional way. Okay, so what's it telling us is went wrong here? I'm missing a quotation mark there, and as we can see, it's the exact same as just doing a normal for loop. Okay, so that's us done the iteration, and just like the list, we can also make it mutable and add extra things to it. So if we want to make this mutable, the exact same syntax as before, mutable list of, but instead of a list, we're going to call map. And then here we can do name to age, and say we wanted to add, Ross. Okay, Ross is here, and we're going to give him the age of 25, right? Now Ross is now a part of this mapping, and we can print out his name here quite simply by doing name to age and index by Ross. Beautiful, right? So this is a basic overview of collections. Two of the most commonly used collections in any programming is lists and maps. So we've covered the basics of these. I think that's pretty cool. So next we're going to talk about functions. So let's get into some slightly more advanced stuff. So you've been seeing me print out this print line, hello world, and you're probably asking yourself, where did this come from? Well, this is called a function, and it takes some input and then produces some output, as you saw. And how you make a function in Kotlin is you just call it fun, and then you give it some name. So for example, let's say we want to do math, right? Let's do some like heavy math. We're going to add some parameters to this. And what are parameters? These are our inputs to the program. So we've got A, which is our int. We've got B. Say we've got A and B, which are two integers that we're going to pass into. And we have an operator, which we're going to say is our character. And we're going to output an int here, and there we go here, and we're going to do some math. We're also, so actually, you know what, I'm going to explain this real quick. So we've got our function, and it's called do math, right? And it's going to do something, and we're going to define that in a second. We've got two parameters here, and we've got an A, which is going to be an integer. Now, like we said before, integers are just your counting numbers, so like 1, 2, 5, 10, 100, negative 100. And we've got B as well, which is also going to be an integer. And now we've got an operator, which we're just going to call character. And this is going to take a plus sign or negative sign, and it's going to return some integer here. So we can define what we're going to return here with a semicolon and int. So we're going to do some math. So we're going to say our result is 0. And when our operator is, we're going to use one of these operators that we talked about before. And when our operator is plus, we're going to do a result is equal to plus b, a plus b, and then if it's a minus, we're going to do a minus b. Sweet. And now we're going to return our result. And return, all that means is whoever called this, we're going to send that value back. and then they can do, whoever called it is going to do, we can do whatever they want with it. So we've got main function here as well, and we're going to call this here. So we're going to do variable, and we're going to say our sum. We want a sum. All we need to do is do math, and we're going to do 5 and 6, and we're going to pass in a plus, right? Now our sum is going to be equal to our result. Hopefully, if we actually output it to the console, we should be able to see it. 11, there we go. 5 plus 6 is 11. Bish, bash, bosh, easy. Right, we're going to do the minus operator, and we get -1. So this is a really dynamic way of doing like programming. You'll be using functions a lot. So that's one way to define a function in Kotlin. We can also do an inline function as well. So what exactly is that? So before, let's say we do another function, we're going to say 2 radians, right? So we're going to pass in this variable called degrees, and we are going to return a double. And a double is just a floating point number, a very precise floating point number. And we're going to do the calculation for radians to, or degrees to radians, right there. Now, what did we do here? We omitted the curly braces in favor of an equal sign. So this is really handy when you just want to return. And we've also, again, omitted the return here as well. This is really handy for when you want to just do one-line functions like this. So in our main here, we can just do, var, and we can do rads, and we can do something like this, 2 radians, and we've got our degrees. Say we want 30 degrees to radians. Rads, and we're going to output this here. And as you can see, we've got radians. And because of floating point error, this might not be exactly correct, but it should be close enough. So lastly, what I want to cover before we move on past functions is I want to cover varchars, or multiple arguments within that function. So say we didn't know how many parameters we wanted to punch in. Say before in our previous example with the do math one, we had 3 parameters. We had the A, we had the B, and we had our operator, right? What if we didn't know how many A's and B's we wanted? What if we wanted to sum a whole list of numbers or parameters, right? There's Kotlin also Kotlin also allows you to do this by applying the var argument method. So we can do this, things.string. So what does this actually do? So this is basically equivalent to passing in a list of things, but instead of actually passing in the list, you're just going to be passing in multiple parameters. So let me just do a quick demonstration of what I'm talking about. So I'm just going to do a quick for each loop, and we're going to do thing, and we're going to print this thing, whatever thing we pass in, right? And so we're going to do it here. So print things here, and say dog, dog, cat, car, there we go, cat, and say stick. Okay. What's this error? Unreferenced print things. things, right? Okay, that's probably wrong. Right. And print line things for each thing via our string things. I have done something wrong here. Just 2 seconds. I will quickly remedy this. So print things for each thing. I am printing an object instead of the actual thing, which should be here. So as you can see, after that quick debug there, we've got dog, car, cat, stick, all printed out with one function with as many arguments as we want. So we can pass in another thing like A, and that will also print as well. So, and that's really nice for when you don't know how many arguments you're going to pass. So that's functions. Next thing we're going to do, and I'm going to quickly exit out presentation mode here, just because I'm going to need to have access to files here, is we are going to define function main Don't worry, we will quickly move past this. We're going to talk about classes next. Actually, you know what? We'll go back in presentation mode just because it's nicer for you guys to see. So we go back into main, and I'm going to give you a hypothetical scenario. So say, for example, we have an object, something, some existence of something. For example, let's say we want to make a club. So let's make a club. So we're going to make the developer student club, right? And we're going to pass this class in here. Don't worry about this. We're going to explain it in a second. We're going to say we want to make a club and we want to give it a name. Say developer student. Sweet, right? We've got our club. That's all cool. And say we want to add some members to our club, right? So add to want to make some members. Okay, so let's say we want to add Jenny to our person. We want to say we want to add Jenny to our club, and she is a person, and that's 3 ends. Jenny, and say we want to give the age of 21 as well. And we've got some other people here as well. So Jenny, let's say Mark and John. Mark and John. And say they're all 21. But you all need to be 21 to join this club. No, you don't. Okay, so this is highlighted red in my IDE because it means that there's no reference to club. And the reason for that is because we've not made a class for it yet. So let's go ahead and do that. So let's say we want to make a class, and let's say we'll start off with the person class first. So within each class in any programming language, think of a class as kind of like an object. So in terms of a human has hair color, they have eyes, they have age, they have a name, but they also do things as well. They can walk, they can talk, they can dribble, they can do complex math, they can do all kinds of things. And these, in terms of objects or classes, these are called properties, which is like your hair color and all that, like we just discussed, and then methods, which is the things that the object will do. So I'm just going to say properties here, and we've got our person, and we're only really concerned in this case about their name, and we're going to define a name, which is a string in our case, and we're also defining an age, which is int. The right kind of int, right? Now in my IDE here, it's yelling at me, it's saying what's going on. This needs to be initialized because, as we said before, Kotlin doesn't allow null pointers, and this is the specific reason why. But we can remedy this with a constructor. Right, now what's a constructor? Don't worry, all it is when you call this person, this is the first piece of code that gets ran. So, and the way to do that within Kotlin is to use this this method name called constructor and pass in the parameters you want to be called with. So as we can see above, we've got name that we want to pass in, and we want to pass in age. So we've got name is going to be a string, and we want to pass in age is going to be an integer. And we open our curly braces, and then we need to access the properties that we just defined. So we've got name here as well, and we've got age. So how do we refer to these the name here and not this name here and this age here? Well, simply all we do is use the this command, right? And this will refer to the object you're talking about. So in this case, it's a person. And we're going to say this name is equal to name, and this age is equal to age. And as you can see, my IDE, it's happy now. Everything's working. It's okay. Now, but another cool thing that Kotlin can do as well is you don't even need to define this constructor. What you can do instead is you can pass these constructor parameters right into the class name up here. So we've got name, string, age, int here, and we can define straight away and just assign these values, age and name, right directly to here. And we can get rid of this constructor, and it makes your code so much cleaner. Personally, I like the constructor just because it's what I've been developing with, but if you like this cleaner approach, you can absolutely use it. So we've made our object class, which is person. We can create people now, and as you can see in the IDE up here, person is no longer red because it's now the program can refer to it. But we still got our club. and our club's red. So we're going to quickly make a club object here. And I am just going to use the constructor way to do this, just because I prefer it. So we've got some properties in a club. Say we want, well, obviously we want to store our members, right? So we want to have a mutable list of members, or people, or persons, right? And don't worry about that wee squiggly line for the time being. It's just there just to tell us that this is null, but we'll fix that in a second. So we've got var name string, and then we've got var, say for example, number of members. Number of members. Integer. Okay. So we've got our properties here, and we're just going to quickly constructor. I am quickly just going to add everything that we need. So up here, we've only passed in one thing, and there's a reason for that, so don't worry about it. We're going to pass in the name, and we've got string here, and this is what all I'm going to pass in is the name. So we can get rid of this red squiggly line for name by defining the name of the club here. And there you go. But these other two properties are still red. And how is that? Well, like I said before, they're null. So we need to instantiate them. We need to actually define something in them. So we're going to do members, and we're going to make a mutable list of members. And we don't need to pass anything into our list, and it'll just be an empty list. And we're going to say this number of members, and we're going to equal this to 0, because currently we don't have any members, so why would we have that? So that's our constructor. Now, before I talked about methods, about classes and objects doing things. Humans do things, clubs do things, right? So in a club, you can actually, believe it or not, you can add people to a club, right? So we want to create, we're going to do this slightly fancy, in a slightly fancy way, and we're going to use our var argument here, var arg, and we're going to pass in members and of type person. So all this is a function within our class. So in our club here, later on, we are going to do something like this, club.add members. And we're going to add Jenny, and we're going to add Mark, and we're going to add John. And we can add as many people as we want. So in this case, what we're going to do is, remember what I said before with the var arg? It's like a list, so we can do a for each in it. And then we can say for each member in our members, we will do this dot members dot add, and we will add a member. And now I'm paying close attention that I'm not actually spelling members as members, because I keep on doing that for some reason. Okay, so next, so if we look up here, this is not added for some reason. So add members, club that add members, and that's because we're not referring to our actual object, which is the developer student club object. Cool. So we can add our members to it, and that's just our methods here. And another cool thing on Kotlin as well is we can do an init, which is whenever any club is instantiated, we can do something. So is it like a constructor? Similar to a constructor, but every time any object is basically made, the init function will be called. So every time we make a club, we're just going to say in our console output, we're just going to print it out and say club has been created. Club has been created, and I am running over time. All right, okay, I'll quickly wrap things up and say we want to function print all members, and we want to print out unit, and we just want to print out all our members here. So members dot for each member, we will member print line, And we're just basically going to print out the members. Yeah, see what I mean, member. Right, so member dot name. And we have to use these curly braces whenever we're referring to a variable within an object with a property within a string. We have to use these curly braces here. And then we quickly do member and not member. Quickly correct these auto corrections. So member dot age, and that should print out all our members. So I'm just going to leave out the number of members for the time being because I'm running out of time and not enough time for you guys to do stuff. So print all members. Quickly run this here. Unresolved reference. Whereabouts is it? Number of members. Let's just close that off here. So as we can see, we've added all our members to our club within our object, Jenny, Mark, and John, which we've all defined here. Now that pretty much wraps everything up that I wanted to talk about Kotlin before you guys get started. My bad that I ran over time. I wasn't even cognizant of it during this. So 2 seconds. I will cancel out of this and just wrap things up. Okay, so what I would have wanted you guys to do, but I think we've just ran out of time, is to go onto this website. You know what? Just do it right after this. There's some activities I wanted you guys to do. Just work through them in your own time, and you can catch up with us in the next study session. I'll make sure to time manage a little bit better next time. I want you guys to go onto this website, which you can access here in Study Jams, and it's just basically a tutorial to get started with the bare bones of Android. Very simple apps, but very, very intuitive in the operation and how they do things. So you can visit in this link here, and I think one of my team members will actually add that link in for you guys to join, and you will collect badges, and at the end of it, you can get a certificate for completing the Android Study Jam. All you need to do is go onto the link, go to New to Programming, and Start Course. And if you have any questions, feel free to join our Discord server and ask the questions there as well. Just because we've ran out of time and we're 20 minutes over, I'm just going to leave it for today. But one thing I would like you guys to do is actually, there is a survey I would like you guys to complete, if you don't mind. That'd be really cool. So I'm just going to post that in here. That's my YouTube name if you're wondering who that is. Just go to that survey for me, please, and just answer the questions, and I'd really appreciate that. If you guys want to learn more, there's some links here. So there's more units in the Kotlin course, and we will actually be covering these pretty soon. You can modify your existing apps and features on them. Feel free to do whatever you want with the code that you're writing, okay? And these are just some additional features and resources to check out. Again, the slides should be published so you guys can check out on this. But yeah, that's everything. And I really appreciate you guys spending time with me here today and doing this live coding session. Apologize that I went over time a little bit, but things happen. So that's everything. Let me know how everything went. Thanks, guys. Actually, you know what? Before I go, I've got a couple of questions here from Stell and Robert. So are maps mutable by default, or do you have to make them mutable? Robert, they are immutable by default. Okay, so if you make beforehand when we were making a map, and it was create a map of, for example, your ages, your names to ages, that will be immutable. You can't change that. You need to specifically say that you're creating a mutable map. And also we have, I can't see the survey link. That's probably my bad. 2 seconds. Vrinda, are you still online? Do you mind trying to get that link, or anyone else in the team try and get that link? I think I sent the wrong one. Perfect, we've got somebody there. Stell was asking, what exactly does the constructor do again? So say you made a person, Stell, right? So me, right? In our codes, when we created the person, the constructor that's the first piece of code that gets launched. And the reason we have a constructor is because we will want to define some properties on our object, for example, my name and age. When we first create our object person, we want to put in our name and age the first time through. And that's all it is. And so that you can really easily just put person, bracket, say John, and then John's age. And that's the reason why we use the constructor. It's just whenever the object gets created, that piece of code runs, literally it. There's some more advanced techniques if you're interested, if you're still, we'll cover those later in the next programming sessions. So I think that's it, everybody. Yeah. Happy programming. So see you.